Good morning, students. Now, I think you remember that in our electromagnetic induction chapter, we have already come up to mutual induction, self-induction, mutual induction. Now, I think you all remember what is self-inductance, what is mutual inductance and all these things. So, today we proceed our next discussion, that is self-inductance of a long solenoid. Self-inductance of a long solenoid. Okay, long solenoid. It's a long solenoid whose whose radius is negligibly small as compared to its length. That is a long solenoid. And let here, if n is the number of turns per unit length of the solenoid, then small n is equal to n by L, where n is total number of turns and L is the length. It is the length of the solenoid. Length of the solenoid. These things. Then, what is the magnetic field inside? The field will be like this. We have already discussed, we have already derived the relation. So, magnetic field inside the solenoid. Inside the solenoid. See, it is B should be mu naught n into I. Okay, I is the current flowing through the solenoid. I is the current flowing. Okay, then what is the magnetic flux? Magnetic flux linked with each turn. Magnetic flux linked with each turn. That should be, I think it should be equal to B into A. Okay, that is equal to each turn. So it will be B into A, mu naught n into I, where I is the current flowing through each turn. Current flowing through each turn. So B into A, that is this value. Then what is the magnetic flux linked with entire solenoid? With the, I want to find it out with the entire solenoid, that should be phi B should be equal to this flux mu naught n I into obviously the number of turns. How much? Mu naught n I, and obviously number of turns from here, total number of turns should be n into L. I hope you are agreed. Small n is equal to capital N by L. That means total number of turns. I can write this total number of turns like this also, mu naught n I into capital N. How much it will be? This value. That means it is equal to, we can write, this is mu naught n square L into I. Now, equating it with standard equation, equating it with the standard equation which we have discussed in the last class. If you remember, that was phi B is equal to L into Y. You can refer to your previous notes, you will be getting it. So, equating it with the standard equation, we get what we get? L is equal to here mu naught n square into L. Look at this. We are getting self-inductance to be equal to mu naught n square into L. Very clear. Mu naught n square into L we can get, and we can also get L is equal to mu naught n by L whole square into L. So L is equal to mu naught n square by mu naught. Sorry, just a minute. I think one term is left, that is A. Just a minute, students. Mu B is equal to mu naught Ni into, definitely A should be there, A into this value. Here also it is A, and I think it is equal to mu naught Ni mu naught small m into I into A. Look, here also it is A. Just a minute. Sorry students, this A was left, so we have here, because it is magnetic flux linked, this should be B into A, into the total number of turns here. So we can write it like this, just you check it. Actually this phi B is equal to total amount B, okay, into A into total number of turns. Actually ये क्या होगा, यहाँ पर मैं तुम्हारे सुविधा के लिए लिख देता हूँ. It is equal to phi B is equal to B into A into total number of turns. Actually होना चाहिए इतना. Phi B is equal to B into A into total number of turns. अब इससे मिला लो. B into A एक टर्न के लिए और into total number of turns. तब ये आ जाएगा. Please just check it. We are getting this. That means how much we are getting? This is A. So here also it is A. Here also it is A. Please. Only very small thing, that only this term A was left. Actually our formula should be this, with the magnetic flux linked with the entire solenoid should be equal to this value, है ना? Phi B is equal to B into A into L. So phi B का वैल्यू कितना हो जाएगा? इतने के बराबर हो जाएगा. ठीक है? ये हुआ अगर if this is air core solenoid. If this is air core solenoid, right? And if there is a material inserted, suppose normally what happens, a ferromagnetic material, iron bar, okay, for the solenoid with core of magnetic material. If there is a magnetic material, then what will happen? In that case, L dash should be mu naught into mu r into L square into A by L, where what is mu r? It is the relative permeability of the material. Relative permeability of the material. Look, ये हो जाएगा एयर कोर सॉलिनॉइड के लिए, और ये हो जाएगा जब वो किसी मटेरियल, कोई मैग्नेटिक मटेरियल को इसके अंदर इंसर्ट कर देंगे. नॉर्मली आयरन कोर इंसर्टेड होता है, ऐसी स्थिति में ये वैल्यू आ जाएगा. इसका मतलब हुआ हमें दो एक्सप्रेशन मिला. वन इज द एयर कोर सॉलिनॉइड एंड इज द मटेरियल कोर सॉलिनॉइड. दैट मीन्स दिस self inductance is depending upon what factors. Let us now discuss on what factors this self inductance depends. Okay, so I write here self inductance. It will depend on, so self inductance of long solenoid is number one, what? Directly proportional to, look, directly proportional to, you can write here directly proportional to n square, right? The number of turns square. Second, also directly proportional to mu r, the relative permeability of the material inserted. Alright? Number 3, directly proportional to area cross section of the solenoid. And number 4, inversely proportional to the length. Look, अगर तुम्हें यह कहा जाए कि बताओ क्या क्या फैक्टर्स पर यह सोलिनॉइड का इंडक्टेंस, सेल्फ इंडक्टेंस डिपेंड करेगा, सेल्फ इंडक्टेंस किन किन फैक्टर्स पर डिपेंड करेगा, इन फैक्टर्स पर डिपेंड करेगा. डायरेक्टली प्रोपोर्शनल टू नंबर ऑफ टर्न्स का स्क्वायर, डायरेक्टली प्रोपोर्शनल टू द relative permeability of the material inserted, it is directly proportional to the cross sectional area of the solenoid also, but inversely proportional to the length of the solenoid. This is an important derivations. Okay.